Okay, before we go to the first content of lecture this morning, as you know that this week we'll be on topic 2, foundation and settlement. So when we talk about foundation and settlement, it can be split into few subtopics and subsections. So go to the lessons plan, then you can see what I am saying right now. For your information as well, this week we covered also topic from the week 5. Week 5, we're going to have only learning activities that you need to participate in the youth future. So for your information as well, even though today or this week we're going to have online lecture, we will also need to take part in this topic 2 teaching videos and do summarize on the respective parts in the videos. And if you feel that some parts is not covered yet in your lecture class, so you may say something on it. For example, haven't covered yet, but you may have some idea what is it talking about. So I want to see your feedback from what you have watched all those parts in the video. And then the important part about taking the LA as part of your teaching and learning activities, because it is counted in your attendance. So I don't want to hear that I forgot to do that, etc. and etc. because I believe that some lecturers has warned you about the attendance must be reached to the 80%. Otherwise, you will be barred from taking the final exams, or you have to pay for fines around 100 ringgit. Okay, once you click this one, start now, so we can count your presence in the lecture class. So as you know that the lecture class plus learning activities are counting for your attendance. So don't forget, once you get into the your future, so please tick your presence in the attendance by having these sections in the your future. For example, right now, you are is a group. I mean that group A, for example. So you need to click here and click the attendance or your name to be that sections to show that you are present in the class. We also taking the evidence from the participants in the empty list. So I don't want you to miss these sections or this role in the U future to take your presence here. So please don't forget that the U future will be open 15 minutes after class begins, and this attendance will be closed 15 minutes after class ends. So please do as much as time you have, so that dia tak ada alasan lah I forgot to tick the feature or etc. Because you just imagine you have spent along the 11 weeks, suddenly you are apart from taking the final exam. Don't you feel that it is something that waste time that you had spent on daripada week 1 sehinggalah week 11? Takkan you nak sia-siakan? I mean that if you have the online learning, it's more easier for you and convenient because you are staying at one place. You don't need to move to class. So just open up your phone and laptop so you can have this online class. Okay, the last issue was about when you share the device for having the for having the attending lecture class. So we only counted the person who joined the empty link only. So those students who shared with the friends without ticking the attendance in the future, so we assume you are not present in the online class. So please be careful and don't do that mistake again. So we go straight to what we going to have this topic. So remember, last topic 1 was about site investigations. So how the site investigation informations will help you to have a geotechnical design such as footing, retaining wall, and also the slope stability. So all the topics are from topic 1, topic 2, topic 3, and topic 4 are related to each other. So you may see that later on in topic 2, 3, 4 are applications in geotechnical engineering. So as you can see here, this is foundation and settlement. So it is having a few parts, and the first part is shallow footing. And also today you're going to estimate settlement, and after Raya, we're going to have a second part of the topic 2, which is deep foundations. So you may see difference between shallow and deep foundations. So when it is suitable to choose or to design to construct shallow foundation instead of deep foundation, or vice versa. So you have to understand what is the bearing capacity and what are the factors and what are the shear mode failures. So these are the things that are important in this topic too. Okay, this is what you may have from end of this topic. So what exactly foundations? Or some book or some people may say footing. So foundation is an interface element used to transmit load from superstructure to underlying soil or rock. So you just imagine, or this structure element you couldn't see because it is underneath ground surface. So if you have a mega structure, or if you have a simple building, so the building loading coming from that structure will be transmitted to the soil. So we have to use one structure element that we call it as a footing or foundation to transmit the loads from structure to the soil. So without this footing, so the loading cannot pass. The loading from the structure cannot be passed through to the soil. So we need to have this kind of the footing, whether you have shallow or deep. So what is the difference between deep and shallow? So you can see that for shallow foundation, it is stated that the ratio between D to B is less than 1, or we can say that the D must be less than 3.0 meter. So what is a D? D is the founding depth. So if you look at here, we have some symbol D. D is a founding depth. Kalau erti kata lain adalah kedalaman korekan tanah. Ada setengah footing will be placed on the ground surface. So maknanya kat situ D sama dengan kosong. But somehow, if you encounter very weak soil, whereby you need to excavate or dig some layer below the ground surface, so that D will be called as a embankment depth ataupun founding depth D. So dia punya syarat macam tu. Kalau you nak pakai shallow foundations, kemudian you punya loading pun tak besar dan dia tak lebih daripada 3 meter, so it is good decision. Tapi kalau kata soil profile or bearing capacity of soil is very low, very weak, you buat standard penetration test, SPT number still could not reach 30 or 50, 34 sand, 54 clay, so you have to opt for deep foundation. The shallow foundation at this particular time is not a good answer to carry load from the structure. So what types of footings? For example, kalau kita nak tengok shallow foundations ni, contoh-contohnya we have a pads, we have strip footings, and we have also mat or rough footing. So selain daripada apa yang saya mention tadi, less than 3 meter depth, and then a mat or etc. footing, so yang tu kita boleh kategorikan sebagai deep footing ataupun example deep footing ni kita panggil sebagai piling, atau kita pakai dia sebagai apa ni, contohnya span pile. Itu antara contoh-contoh yang mana dia bukan lagi sebagai shallow foundations. So you can see the difference between deep and shallow foundations. Okay, how to classify shallow foundations? Again, there are many types of shallow foundations. You can see on the right side here, we have a wall footing, and then we have a pad footing. If you go to the village, for example, kebanyakan kalau ada lagi rumah-rumah kampung, you may see a pad footing on the ground surface. Yang mana rumah kampung tu dia punya tiang berada pada satu blok batu contohnya kan. So the block batu ataupun that particular thing we can consider as a shallow pad footing. Okay, what are factors that control to the choosing right footing? It depends on the dead load, for example, live load, kemudian wind load ataupun earth pressure kalau kita ada extra loading, and then other factors such as water pressure ataupun earthquake forces. So these are the things ataupun factors that contribute to the structural effect or structure loads. Okay, as I said, in this topic 2, 3, 4, you may see that how are we going to design geotechnical applications. For this example, topic 2 is on the foundations. Macam mana kita nak design foundations? Tadi you dah tengok foundations ada dua jenis, ada deep, ada shallow. But this particular week, we're going to concentrate on shallow foundations only. For the purpose in designing shallow foundations, there are three factors you need to consider. The first one is the adequate depth, second one is a limiting settlement, and the third one is the factor of safety against shear failure. So it must comply all these three factors. Kalau kata you design shallow foundation, what does design means? Design means that with the particular intensity loading from column ataupun structure load tu, bila kita kenakan kepada footing, kita nak design the correct dimensions of the footing so that it can cater the load without having soil failure. The soil failure may have in general shear failure, for example, ataupun local shear failure, ataupun dia akan fail dalam punching shear failure. So benda-benda tu yang kita nak tengok, adakah dia punya B dia cukup, kalau kata founding depth banyak ni, B banyak ni, dia punya bearing capacity tinggi ke, rendah, factor of safety dia berapa. So these are the things that you have to look at. And then the limiting settlement cannot be reached from the tolerable amount. For this particular design, kita akan pakai design concept or requirement from British Standards ataupun Eurocode 7 Geotechnical Design. So I believe that if you go to the next advanced geotechnical engineering, you going to learn how to design shallow foundation using the Eurocode 7 practice. Okay, this is examples what you may have in the adequate depth, meaning that must be sufficient to prevent any adverse effects due to changes in surface conditions such as climate changes, actions of freezing and thawing, temperature changes. Also important when dealing with horizontal loads or strong overturning moments. And the limiting settlement is depend to the types of settlement, whether you have total settlement, differential settlement, or you may have angular distortions. And also the functions of the building itself. Okay, dari segi economical aspek dia macam mana kan, ataupun kalau you construct footing, pad, mungkin limiting settlement dia berbeza on sand ataupun on clay. Kalau you construct or you design shallow foundation menggunakan strip type, so limiting settlement berbeza. So it depends kat mana dia berada, pada jenis tanah apa. Kemudian the tolerable amount of the settlement that allowed in the practice code. And then the factor number 3 is the shear failure occurs when the soil divides into separate blocks or zones which move fully or partially and tangentially with respect to each other. So what's the factor of safety? Is the meaning or the ratio of the shear strength of the soil to the maximum mobilized shear stress must not be less than the appreciated value. It means that when you want to design any geotechnical applications, you may see that, okay, this is the factor of safety that we need to meet the requirement. If you calculate, then you got the factor of safety, for example, less than 2, which is not acceptable in the design practice. So you have to redesign, change the dimensions of the footing, change the B, change the D, for example. So that's how something that we check on design stage. Okay, this is example for limiting settlement. If you have any types of footing placed on the sand, for example, ataupun placed on the clays. So you can see that there's a difference tolerable settlements for kind of total, kemudian maximum differential settlement between adjacent column. This is what you can see if you have isolated footings, for example, 40 millimeter, and then kalau kata footing you isolated footing on clays, so dia punya limiting settlement is 65 millimeter. As you remember, why it's only concentrate on these two major group of soil, sand dan juga clay, ataupun kita kata lain, dia adalah coarse material dan juga fine material. Kalau ikutkan sands and clays ni, kita can divide, kita can split, categorize into few sections ataupun few groups. For example, sands, you may have a loose sand, for example. You may have also dense sands. Kemudian clay, kita ada normal consolidated clay, kita ada over consolidated clay. All those kinds of soils, sama ada sands, clays, they have different properties. So the different properties ni can be found from the site investigation data ataupun from the experimental work. That's how it is come back from the topic 1, yang mana kalau you remember balik daripada apa yang you dah belajarkan daripada topic 1 tu, is relate on the how to obtain the distant sampling, undistant sampling, why you have to put more attentions on the undisturbed sample, because we want to prevent any disturbance that may have effect to the soil properties. So these are the things why it is very important you understand from the topic 1 to the topic 2 and to the last one, topic 4. Okay, as I said, one of the factor in the design shallow foundation is a factor of safety against the shear failure. So for your information, there are 3 modes of the shear failure. You can see from this image, figure A, figure B, and figure C on the left side here. The A is a general shear failure. If you look at from this A, once you apply loading or this kind of column structure, so there is a settlement ataupun you akan nampak footing ni move downward. So the downward movement occur from this one will create to this kind of soil having some kinds of bugging. Maknanya bugging tu akan move outward from the edge of the footing. So in this particular, you akan nampak the plastic failure zone have some particular angle. So ini selalunya untuk general shear failure, it is occurs in the dense sands ataupun over consolidated clay. Tapi bila you ada this kind of very weak soil, for example, contohnya soft soil, kemudian loose sand, and then normal consolidated clay. Bila you letak footing on that types of soil, you akan nampak very little bulging. Tengok dekat bahagian tepi bucu footing ni, dia punya tanah dia punya bulging tu dah makin kecil berbanding general shear failure. So if you make comparison untuk punching shear dibandingkan dengan general shear, local shear, of course dekat punching shear there is no more at all bulging, very sikit, tapi yang berlaku adalah tilting. Tilting ni dan juga drag down. Yang mana dalam keadaan ni punching shear is the worst shear failure for any weak soils. So we try to prevent or we try to assume that any foundation dia pergi kepada general shear failure saja. Kalau dia pergi sebagai sampai ke punching shear failure tu, dia akan give you a worst scenario of the foundation ataupun structure failure. We try to prevent that things happen. So this is the recommendation factor of safety number for reference if you dealing with the design, contohnya railway, kemudian highway bridge, and then apartments. So as I said lah, ada practice dia start dengan 2.0 factor of safety. Ada yang accept sebagai 3.0. So depends on the purpose of the structure and then the loads carry and then the limiting settlement. Okay, I think that this one is very common things that you have to see when you are dealing with the design for shallow foundation. For example, dense soils ni resulting in general shear failure. Kemudian kalau kita ada loose soil ni, dia akan create to the local shear failure, whereby very loose soil can fail by punching shear failure. So it is more expected settlement in loose soil compared to the dense soil. And then the expected failure surface for general shear failure consists of rigid wedge. Okay, we go to the next sections of this lecture today. Shallow footing. There are few definitions and terms that you have to understand before you can estimate the bearing capacity of the soil and footing as well. Okay, the first term, ultimate bearing capacity, QF. So it is defined as the intensity of bearing pressure at which the supporting ground is expected to fail in shear. Maknanya macam saya cakap lah, kita ada structure. Structure tu akan memindahkan beban daripada superstructure, mega structure atau apa ke benda building. Kemudian dia akan pindah melalui footing. Footing pula akan pindahkan beban yang ditanggung kepada tanah. So kita nak tengok Is it the soil can cater the loads carrying from top? Okay, macam mana kita nak tahu tanah tu boleh tanggung ke tak boleh tanggung? So look at to the bearing capacity QF. So you have to calculate the bearing capacity of the soil. And then what is the net ultimate bearing capacity? So the net ultimate bearing capacity is something that you subtract from the overburden pressure. So kalau you tengok dia punya simbol sekarang ni dia dah ada Q and F. Okay, forgot to tell you is that ada setengah buku dia menggunakan ultimate bearing capacity as a QU. Macam dalam nota ni saya menggunakan QF. It's okay, it's bring the same meaning. But my suggestions to you, since you are referring to this note and I'm teaching you this topic, so you have to follow as what I have shown you in this class. So kalau saya kata saya guna QF, so you pun kena guna QF. Yang lain, term-term yang lain samalah macam net ultimate bearing capacity. The only difference satu lagi dekat bahagian factor of safety. Sebab factor of safety ni dia ada banyak teori, banyak approach untuk bagi different value of FOS. Sama ada dia overestimate conservative value ataupun non-conservative value. Okay, the second term is the net bearing pressure. Tadi bearing capacity kan? Okay, net. This one is a net bearing pressure. It's coming from the loading applied to the soil. So it is the net foundation pressure ataupun net loading intensity. So yang ni berkaitan dengan soil. Yang ni berkaitan dengan loading yang bertindak kepada tanah tersebut. So the net change in total stress experienced by the soil at the base of the foundations. So the difference between the total applied stress Q and the stress removed due to the excavations. So the Q here is not Q kat sini merujuk kepada intensity loading. Intensity loading is coming from the superstructure loads. Sama ada column ataupun apa-apa apply loading yang lain lah. So by definitions kat sini dia punya abbreviations tu ataupun if you look at to this image, it shows you that how you can get the Q kecil ni. Q kecil lain dengan Q besar. Q besar ni unit dia dalam kilonewton, dia adalah load, beban. Tapi kalau kata Q kecil ni dia adalah pressure, net bearing pressure. It's a contact pressure. Contact pressure pada base footing. Contact pressure daripada loading ni at the base footing. So kita akan calculate dia sebagai P over A. Kalau tak P, kita ambil Q lah, iaitu loading dari kolom bahagi dengan area of the foundations. Okay, what is the sigma naught? Sigma naught is the overburden pressure ataupun pressure relief due to excavations. So in this particular figure, image showing to you that untuk overburden pressure, dia adalah stress relief from excavation. Remember just now I said footing you can be placed on the ground surface ataupun it is founded few meter below the ground surface. Kita pakai sebagai D lah, founding depth. So dekat founding depth tu dia akan create to you some overburden pressure kalau dia berada beberapa meter daripada permukaan tanah. So how to calculate the overburden pressure? The overburden pressure ni is also depends on the groundwater table effect. Kalau kata dia ada kesan groundwater table, so dia akan dapat effective overburden pressure. Tapi kalau kata the soil conditions is totally dry ataupun bulk, so there is no water table effect. So kita akan calculate dia sebagai total overburden pressure iaitu gamma darab dengan D. What is a gamma? Gamma is a unit weight of soil. D is a founding depth. So when I explain you this topic is actually I try to bring you together, remember what you have learned in the soil mechanics. So ada setengah simbol ni kita dah jumpa dekat dalam soil mechanics. So I don't forget pasal topik ataupun course yang lama. So kita akan guna semula untuk topik geotechnic. Okay, the next definitions is a factor of safety is defined as the ratio between the net ultimate bearing capacity and the net bearing pressure. So bila cerita pasal net ni selalunya dia kena minus dengan overburden pressure. Net bearing pressure ni adalah contact pressure Q tolak dengan overburden pressure. Tapi ada setengah teori macam saya cakap lah, formula dia berbeza. Nanti you akan nampak kemudian lah. Okay, the next term is a presumed bearing value. It's a conservative value to a rock or soil. It's preliminary design purpose. So use the empirical data, consideration the width of foundation, the probable settlement, limits and local experience. Okay, the next one, definitions on allowable bearing capacity, QA. So the QA depends or must be satisfied from two criteria. The first one is a settlement. The first one is a shear strength, and then the second one is a serviceability limit state value, iaitu settlement. So bila kita nak calculate allowable bearing capacity ni, by definition is the bearing pressure that will cause either undrained or drained settlement or creep equal to a specific tolerable design limit. Maknanya kita dah limitkan this is the amount. Maknanya apa benda yang you design ultimate bearing capacity ke apa ke, dia tak boleh exceed from the allowable bearing capacity. So it must be satisfied from this term, strength dan juga settlement. Settlement ni bergantung sama ada you have immediate settlement or undrained settlement, or you may have the consolidation ataupun drain settlement. Selalunya immediate settlement ni dia bergantung kepada short term stability lah. Kemudian untuk consolidation settlement ni dia bergantung kepada long term stability. You nak tengok after 10 years, after 20 years, settlement tu ada tak lagi berlaku perubahan in terms of displacement? Ada tak creep? Kalau kata masih lagi ada berlaku settlement, so kita kena ambil sebagai B punya formula lah untuk calculate the allowable bearing capacity. Okay, before we can calculate the ultimate bearing capacity or whatsoever term dalam topik tu ni, untuk shear foundations, so there are assumptions made by Terzaki lah. Kalau you tengok sini, contohnya soal kita adalah semi-infinite, homogeneous, isotropic, weightless, rigid plastic material. Kemudian founding depth DF must be less or less than the width of footing. And then it is assumed that as the footing fail in generation failures, kemudian the failure zone is actually having an angle 45 plus effective P over 2. Kemudian the shear strength of the soil above the footing base is negligible. Okay, however, Meyerhoff considered the shear above the footing base. Okay, the soil above the footing base can be replaced by surcharge stress. So the base of the footing is rough. So it is assumed that way lah kalau tersegi. Tapi sebenarnya nanti you akan nampak bila kita calculate settlement sama ada immediate settlement, dia bergantung kepada jenis footing awak. Sama ada you ada rigid footing ataupun flexible footing, kemudian you ada rough footing ataupun you ada smooth footing. Okay, we go to the first one on the term ultimate bearing capacity. Okay, in this term, for ultimate bearing capacity, it consists of three terms. For the first term, it represent coefficients. So kalau kata footing you on clay, for sure you can have the first term. Tapi kalau kata footing you on sand, mostly kalau kita tengok sand, dia hanya ada nilai internal friction angle, phi. So bila footing you berada on sand, so kita boleh kata term nombor 1 eliminated. Tapi untuk term nombor 2, sama ada footing you on sand ke clay ke, dia masih lagi maintain. Term nombor 3 dia berkaitan dengan unit weight. Unit weight di mana footing tu berada. Footing tu placed on what type of soil. And then apa dia punya unit weight. Kan sama ada unit weight dia dalam bulk ke, dalam keadaan dry ke, ataupun dalam keadaan fully saturated. Okay, taking one example, if you have a straight footing. So this is the general equation for straight footing, consists of C and C plus overburden pressure NQ plus half B gamma and gamma. So NC, NQ and gamma are bearing capacity factors. So they bergantung kepada angle. So one thing that you have to remember, macam saya beritahu tadi, footing ni, shallow footing, kita ada pelbagai bentuk, ada pelbagai jenis dia. Jenis maksud kat sini saya bukan merujuk kepada jenis material footing tu dibuat. Saya maksudkan kat sini adalah the type of the footing itself, sama ada straight footing, circular, square ataupun rectangular. So when you look at closely, according to the Terzaki formula, when you have different types of footing, sama ada straight, circular, square, rectangular, the automatically changes on term first dan juga third terms. Untuk second terms, dia akan remain constant. So, when you want to answer the question, read question carefully untuk you tahu kat mana formula yang kita nak pakai. So, contoh tadi, kalau formula atas ni, dia menggunakan strip kan? That's why you akan nampak CNC plus overburden pressure NQ plus 0.5 B gamma N gamma. Kalau soalan tu kata footing tu adalah circular footing. So, apa cara nak buat? You akan ambil 1.3 CNC campur dengan overburden pressure NQ campur dengan 0.3 B gamma N gamma. So, itulah perbezaan antara setiap shape, circular, square and rectangular. Kalau you look at all those terms ni, tersegi dia made simplified assumptions yang mana footing you dalam keadaan vertical. Dia bukan dalam keadaan inclination. Maknanya kalau you nak letak footing on slope yang ada certain angle, so the tersegi formula is not applicable anymore. So you kena carilah formula lain. Okay, ini macam saya cakap tadi, bila you nak calculate term number 3 ni ataupun you nak kira overburden pressure, dia bergantung kepada water table effect. That's why kat sini dia tulis reduction in effective unit weight due to the ground water. Okay, water pressure load ataupun ground water table effect on QF. QF is ultimate bearing capacity. So if the ground water table is between the ground surface and the foundation at position 2, for example, so the effective overburden is duly determined for the terms second and third term use gamma effective. So apa maksud dia? Kalau kita go through one by one cases ni, daripada case 1, case 2, 3, 4, 5. Okay, case 1 ni di mana air tu ataupun water table effect on the ground surface. Meaning that the soil below ground water table ni is fully saturated. Bila you calculate overburden pressure dalam term number 2, kemudian you calculate unit weight dalam term number 3, dia akan bagi you effective value. Sama ada effective overburden pressure ataupun effective unit weight. That's why kat sini kalau you tengok untuk term number 2 yang mana dia adalah overburden pressure term. So dia akan pakai effective unit weight iaitu gamma soil tolak dengan gamma water. So in this topic, I very strictly to remind every students that please use the value 9.81 to represent unit weight of the water. So jangan guna 10 sebab saya standardizekan for the unit weight of salt, the unit weight of water is 9.81 kilonewton per cube meter. So kalau kata unit weight soil ni is 20, so 20 minus dengan 9.81 times dengan D. What is a D? D is a founding depth. Berapa kedalaman yang kita korek tu? So kita darab lah untuk dapatkan overburden pressure. Okay, same goes to term number 3. Kalau tadi term number 2, kita dah guna effective unit weight. So the term number 3 pun, kat mana pressure, bearing pressure yang kita nak estimate? Kita nak estimate dekat base footing kan? Base footing kita ni is fully saturated or have the water table influence. At this particular time, gamma yang represent tanah di mana footing tu berada mesti dikira dalam unit efektif. Dia tak boleh ambil sebagai unit weight biasa ataupun total unit weight. So gamma saturated tolak dengan gamma water. Case number 2, air tu berada beberapa meter daripada permukaan tanah. So that's why dia panggil intermediate. At this particular sections, you akan nampak D ni dia dah bahagi kepada 2 section. Satu section dry, kat sini dry. Dekat bawah daripada water table ni adalah section wet ataupun saturated. So in this particular time, when you want to calculate the effective overburden pressure, you kena ambil, maknanya you have to carefully calculate the overburden pressure. Counting from the dry conditions plus dengan wet condition. For example here, kalau kata above the water table effect ni, kita akan ambil gamma soil biasa darab dengan ZW plus dengan Sebabkan tanah yang bahagian wet ni dia dah ada effect of water table. So dia akan pakai effective unit weight iaitu gamma soil tolak dengan gamma water darab dengan HW. Okey, itu untuk kes nombor 2 intermediate. Okey, macam mana pula kita nak kira term nombor 3 untuk kes nombor 2? Okey, you look at dekat mana footing tu berada at which particular soil. Kemudian tengok soil tu ada efek air ke tidak. Kalau this case, sebabkan footing kita ni berada di bawah the symbol ataupun below the influence water table. So of course, gamma untuk term nombor 3 ni kita kena ambil gamma saturated minus dengan gamma water. Okay, untuk kes nombor 3 iaitu water table at the base of footing. So at these sections, you akan nampak above this water table influence, tanah kita dalam keadaan dry. That's why kat sini dia pakai total overburden pressure. Tetapi untuk term number 3 iaitu footing placed on the soil weight. Unit weight yang mana kan? Sebabkan water table tu berada at the same line of the footing dan juga water table influence. So dekat term number 3, unit weight tu kita akan pakai effective unit weight. Okay, untuk kes number 4, dia bergantung kepada influence of the passive zone. If you have water table above the passive zone ataupun water table awak berada di bawah passive zone. So passive zone ni dia indicate dengan this dash line lah. Macam mana nak kira passive zone depth DW tu adalah D campur dengan V. And that is represent as the DW. Ini adalah DW. DW sama dengan D campur B. Kalau kata water table above the influence line, passive zone tu, so kita punya term number 2 sama macam case number 3. Tetapi untuk term number 3 ni dia ada perubahan sikit lah calculation dia. So you kena pakai this formula. Dapatkan DW tolak DF. Tapi kalau kata case yang mana water table is below the passive zone. Kat sini passive zone awak. Kemudian water table tu berada di bawah. So at this time, you akan nampak there is no effect of water at all pada term number 2 dan juga term number 3. So dalam keadaan ni kita kata the soil is fully bulk ataupun dry. So there is no influence of water table. Okay, how to obtain NC, NQ and gamma? Dia bergantung kepada teori lah dan juga phi. So as I said, kalau the footing placed on clay, you akan nampak di sini. Contohlah kita pakai table yang daripada Hansen lah kan. Okay, bila kita letak footing on clay, phi dia kosong kan. So NC kita 5.14, 1 dan juga kosong. Tapi kalau kata contohlah awak ni footing placed on sand, phi dia sama dengan 40. So kita akan ambil NC 75.3, kita akan ambil NQ 64.2 and gamma 95.5. Okay, itu cara untuk dapatkan NC, NQ and gamma ataupun bearing capacity factor. Okay, yang ni pun sama juga macam saya explain. Dia bergantung lah daripada bearing capacity factor tadilah. Dia just showing balik untuk ultimate bearing capacity dan juga net ultimate bearing capacity. As I said, kalau dia melibatkan net, you kena tolak dengan overburden ratio. So, bila kita ada footing on sand, kalau you perasan kat sini, term nombor 1 tu hilang. Pasal apa term nombor 1 hilang? Term nombor 1 lah, contoh kita ada strip footing lah. Formula ni berkaitan dengan strip footing. C kita of course kosong kan. So bila kita substitute dalam this formula, C kosong, baik tak payah tulis langsung term 1 kan. So yang tinggal hanyalah term 2 dan juga term 3. Tapi sebabkan you nak calculate net ultimate bearing capacity, so you kena tolak dengan overburden pressure. Tapi kalau you letak footing you on clays and silt, yang mana phi sama dengan kosong, that will be affected untuk case ataupun term number 3. Iaitu 0.5 P gamma N gamma. Kenapa term number 3 tu kosong? Sebabnya bila kita tengok balik daripada tabel tadi, C sama dengan kosong, N gamma kosong kan? So bila you substitute balik dalam this formula, you akan nampak N gamma kosong. So yang tinggal hanyalah term number 2 dan juga term number 1. So ni term 1, ni term nombor 2. CU and C gamma efektif darab dengan D. Okay, kenapa bila dia net ultimate bearing capacity, the only left is CU and C? Ada jawapan tak? Any questions? Sorry, any answer? Any answer? Okay, tak apa. Yang tu saya tinggalkan awak untuk dapatkan jawapan dia. Untuk case footing on clays, dia ada conditions yang mana kalau undrained condition tu kita boleh menggunakan Scampton chart untuk dapatkan nilai NC. So, dia bergantung kepada faktor footing shape, kemudian D over B, and this is how it's easily it shows to you that the NC value. Okay, ni adalah net bearing pressure, saya dah explain. Okay, as I said just now, for terzegi, dia tak boleh nak design ataupun dia tak boleh nak calculate ultimate bearing capacity if you have footing on inclined area ataupun inclined angle. So at this particular sections, during this time, kita dah tak pakai terzegi punya formula, kita akan pakai basic formula. Sebab apa? Dalam basic formula, selain daripada beside it is introduced the bearing capacity factors, coefficients, it also introduce to you the shape factors. Dalam shape factors ni, you akan tengok kita ada shape factors rely on the inclination, bergantung kepada shape itself. So you can see that kalau kata footing you are having a different shape, you akan ada different shape factors. What is the shape factors ni? Shape factors seperti SC, kemudian depth factors, kemudian inclination factors. Ini yang saya maksudkan. Kalau kata footing you berada pada pada permukaan tanah yang bercerun, so kita dah tak boleh pakai terzegi. Kita eloklah pakai Meyerhof ataupun Hansen because it considered shape factors, depth factors dan juga inclination factors. Okay, this part pun I have explained. Okay, this is shows you how to identify masa bila kita nak guna terzegi Hansen ataupun basic. I explain just tadi macam saya cakap lah. Kalau terzegi dia tak boleh pakai incline slope kan. So kita pakai basic. Kalau takat biasa-biasa tu je kita boleh pakai formula terzegi. Tapi untuk calculate ultimate bearing capacity I am recommended you to calculate the allowable bearing capacity ataupun safe net bearing pressure tu, safe net bearing capacity dengan formula dia adalah this one Q and F bahagi FOS plus dengan gamma D. So this is the safe net bearing pressure. Kalau you tengok pada pelajaran MDAS pelajaran MDAS dia just straightforward guna sebagai Q allowable sama dengan Q net ultimate bearing capacity bahagi dengan FOS. So that particular formula bukan salah, dia tak salah. Cuma dia punya calculations tu dia akan give you conservative answer. But I am preferring to have this kind of the formula iaitu safe net bearing capacity menggunakan this kind of the this formula lah, atau dipanggil sebagai ada setengah author tu macam yang ni Mat Manzur Ahmad, kalau this kind formula disebut sebagai safe gross bearing capacity. Tapi kalau you tengok the same formula stated by Mat Manzur Ahmad in the row with law, dia panggil lain, dia panggil sebagai allowable bearing pressure. So all those things dia punya formula sama tapi the way it's bring meaning tu berbeza. So you have to read question carefully, look at to the appendix what are given to you untuk you guna dalam dapatkan jawapan. Okay. Okay, untuk example, I show you later. Cuma saya nak concentrate lah to the last sections of this part, iaitu settlement. As I said earlier, once you place footing on the soil, you akan nampak some resulting in movement. Iaitu kita akan nampak vertical downward movement. Dalam erti kata lain, kita panggil dia sebagai settlement. Okay, dalam settlement ni, you boleh tengok settlement for the immediate settlement, primary consolidation settlement ataupun secondary settlement. All the type settlements ni dia bergantung kepada time you measure tu. Kalau kata you nak dapatkan the immediate settlement after you place loading, maknanya pada waktu ketika pada saat tu kita panggil dia sebagai immediate settlement. Tapi kalau kata you want to have the settlement after consolidation reach 100%, so itu kita panggil sebagai primary settlement. Tapi kalau kata you dah yakin dah your building is safe, consolidation dah reach 100% and then all those buildings are constructed, and then you nak tengok the future effect ataupun currently you tengok dekat rumah-rumah yang dah diduduki macam rumah parent you ke apa kan, ada tak some kinds of the crack ke ataupun sebab settlement ni kita tak boleh nampak secara mata kasar melalui pergerakan tanah. Dia punya effect tu apa-apa movement, soil movement, the effect will be on the surface of the structure. Contohnya you akan nampak crack structure, kemudian you akan nampak kolom dengan wall tu ada sedikit rekahan, ada gap, kat situ adalah resulted from the movement. So itu kita panggil sebagai secondary settlement. So the cause of settlement is the reductions of volume air void ratio in the soil. So itu antara punca secara teori lah kenapa settlement tu berlaku. So bila kita nak differentiate settlement, settlement yang ada jenis uniform, ada yang jenis differential settlement. So kalau uniform settlement ni you akan nampak dia punya amount settlement on the left right sides of the building are similar. Tapi kalau you nampak some kind of tilting sedikit kan, building tu menyengit, so you akan nampak the differential settlement between on the left and right sides of the building, on the side of the building. So dalam this things untuk differential settlement, dia dah set limiting berapa yang dibenarkan untuk isolated footing ataupun you ada major structure. Okay, the cost of foundation settlement ada yang direct effect ataupun direct cost, ada yang disebabkan oleh indirect cost. Contoh direct cost ni as I explain in the earlier class tu, jenis-jenis loading kan. Sama ada dead load ke, kita ada live load ke, kita ada earthquake. Ataupun indirect causes, contohnya failure of collapsible soil, kemudian failure of underground tunnel ataupun mines, collapse of cavity of limestone and etc. Okay, yang ni pun saya tak explain sebab saya rasa you dah jumpa dulu. Okay, settlement ni, it can be measured from theoretical base ataupun from field measurement. So field measurement ni contohnya plate bearing test, pilot test, SPT, CPT dan juga JKR probe test. Okay, macam mana kita nak estimate settlement? Settlement ni, as I said, untuk different type of settlements, dia akan memberi value yang berbeza lah. Bergantung kepada jenis foundations you, soil properties. Kalau macam contoh ni, if you have this kind of red lines, it is settlement from the rigid foundations. Kalau kata you ada blue line, that is the pattern of the settlement for flexible footing. Okay, dia juga bergantung kepada nilai E dan Poisson ratio, the founding depth, also the H. Okay, kita boleh pakai formula daripada Terzaghi, Scampton untuk estimate the settlement. Okay, on the left side here, this is how the theory to calculate immediate settlement and how does it is reflect from the footing types and the locations of the footing positions. sama ada footing awak tu berada dekat center, corner ataupun average for rigid footing ataupun for the smooth footing. So you can see from this value how to obtain the influence factor, for example, ataupun you want to have the correction factor for founding depth. Kalau you are using the Jambu method, you need to get the coefficients of new A here on top and bottom figure. Okay, kalau kata you want to estimate settlement from the field measurement using the CPT, so this is how it is. You have to divide soil into few layers. Kemudian you kena dapatkan cone resistance, get the influence Isaac tu and do the multiplying untuk dapatkan the total settlement of the soil layers. Okay, ini based on theory. Based on theory ni, kalau you remember dulu, if you plot from one-dimensional consolidation test on the graph paper, so kita akan, ataupun kita boleh estimate lah consolidation settlement. Dengan erti kata lain, you have the coefficients of volume compressibility, kemudian the changes in vertical stress, and then you know the initial thickness of the clay. So don't forget also, if you remember, the changes in effective vertical stress is due to the contact pressure dan juga influence factor IR ni. So it depends also the positions of your footing, sama ada at the corner ataupun at the center ataupun at the edge of this soil layer. So you need to calculate the influence factor dulu, kemudian darabkan dengan contact pressure, then you can have the changes in vertical stress. Masukkan dalam this formula, so you akan dapat the consolidation settlement. So somehow it can be estimated from the plate bearing test, kemudian daripada standard penetration test. So standard penetration test, as you remember, kita rely on the SPT number. So ada SPT number yang kena buat corrected lah. So dia tak boleh direct use from the site data. Okay, the next slide here showing to you how to calculate the immediate settlement. But I won't touch on details in this part. I leave it for you to have your own study. So let us have 5 minutes break before I go or I return to the example calculation for ultimate bearing capacity. So do you have any questions before we continue dengan ultimate bearing capacity after 5 minutes break? Okay, let's just have 5 minutes break, yeah. Okay, we are back. So do you have any questions just now? If you look at to the lesson plan, if I'm not mistaken, for your test 1, which will be held next Friday, I hope that you are not confused on the things. For example, open 9 a.m. to 6 p.m. Meaning that the questions or the system set to the question be there will be open from the 9 a.m. to the 6 p.m. You are you are allowed to answer within the time given, and the time taken to answer the questions is only 1.5 hours only, even though the system is open from 9 a.m. to 6 p.m. And please don't do at the last minute because I'm afraid that while you are trying to do submissions, the system locked already. So when it is happen, you cannot submit anymore your answer script. So tolong faham dengan jelas lah, walaupun apa tu sistem tu buka daripada pagi sampai ke petang, you boleh jawab pada bila masa you free. Kalau kata pukul 10 pagi you ada kelas, you janganlah jawab pukul 10 pagi kan, nanti tak ada dengan nak jawab soalan lah, dengan nak dengar kelas kan. So test ni will be closed book, so dia bukan buka. Yang buka tu sistem je buka sepanjang 9 sampai 6. Kemudian topik yang di cover, whole topic 1. Kemudian topik 2, if I'm not mistaken, so only on the shallow foundations lah. Kalau kata dia cover semua tu, exceptional for deep foundations. Deep foundations kita akan cover selepas cuti raya. So hopefully you tak confuse dekat situlah dari segi masa dia, soalan apa yang nak kena study apa semua benda kan. Okay, back to this one. Memandangkan this one is one thing that important dalam shallow foundations. As I said, how to ensure that your shallow foundation is safe in terms of the designs. So you kena check lah on the ultimate bearing capacity. Kemudian you kena calculate the allowable bearing capacity, ataupun you have this value antara Q ultimate dengan Q allowable, so you nak dapatkan factor of safety. So berapa nilai dia kan? So this example, kalau you look at to this one, you are given a square footing dengan size 1.5 times 1.5 meter. So you look at from here also, you akan nampak footing ni is not placed on the ground. Dia dikorek untuk diletakkan pada kedalaman 1 meter. Soil properties 17.8, Phi 20, C 15.2, FOS 4. So dalam soalan ni juga, you tak payah risau pasal NC, NQ and gamma sebab semua dah diberi. You just verify baliklah betul ke pada Phi 20, nilai NC, NQ and gamma seperti yang you dapat di sini. Apa yang saya nak stresskan adalah how are you going to determine the ultimate bearing capacity for different cases of the water table effect. So yang tu yang saya nak you nampak perbandingan dia. And then for this particular question, saya tak test untuk semua jenis footing. I only tested on the square saja sebab soalan ni dia dah bagi square footing kan, so kita hanya nak tengok square footing ultimate bearing capacity untuk kes pertama air macam mana, kes kedua air macam ni sampailah kes nombor 5. So that's why kat sini you can see that the groundwater table at ground surface, kemudian intermediate at the base foundations, and then within the B depth above the passive zone, DW sama dengan 1.5 meter from ground surface. So ini adalah benda-benda dia. Okay, I just show you one example here. For example, with the effect of water table at the ground surface. So this is quite easy lah sebab as I told you, untuk all the terms that are in the formula. Before that, you kena tahulah ultimate bearing capacity formula untuk square footing. Itu yang penting sebab kita tak nak you salah guna formula lah. Kalau macam square footing kat sini menggunakan Tzerski theory. So first term is 1.3 C and C, kemudian Q, second term is maintain. So third term is 0.4 B gamma and gamma. Okay, macam saya beritahu, water table berlaku dekat atas kan. So, apa yang terkesan adalah overburden pressure pada term number 2 dan juga unit weight pada term number 3. So, kita akan tolak dengan 9.81. Term number 1 dia tak akan ada efek sebab dia hanyalah C. C ni mewakili soil properties iaitu dalam disk kan dia maybe silty clay ataupun sandy silk. So, kita kira macam biasa 1.3 darab 15.2 iaitu C efektif and C adalah 17.7, so kita dapat 349.75. Untuk second term, sebabkan soil below the ground surface is fully saturated, kemudian kita nak calculate dia sebagai effective overburden pressure. Thus, unit weight must be minus dengan 9.81. Unit weight of soil tolak dengan unit weight of water, darab dengan founding depth 1, darab dengan NQ, so you akan dapat 59.13. Kemudian term number 3, footing ni, base footing ni berada pada unit weight of soil yang ada water table effect. So, the unit weight in this term number 3 must be calculated as a effective unit weight. So, you tak boleh ambil sebagai total unit weight lah. So, 17.8 unit weight of soil tolak dengan 9.81. So, you darabkan dengan N gamma dia dengan 0.4. So, you akan dapat 21.09. So, you total up lah term 1, term 2, term 3. So, you akan dapat 429.97. So, ini case kalau air dekat atas. Kalau kita pergi case nombor 3 iaitu water table at the base footing, base foundations. So, at this particular time, you akan nampak term number 1 maintain, term number 2. Okay, term number 2 sebabkan water table berada at the base footing here. So, above this one will be in the bulk conditions. So, kita akan pakai total overburden pressure ataupun total unit weight of the soil. So, that's why kalau you tengok pada case number 3 kat sini, so, you akan dapat 17.8 darab dengan 1 darab dengan NQ 7.4, 131.72. Berbeza untuk term number 3 iaitu unit weight dia ni sebabkan water table at the same line of the footing base, so dia akan ada effect water table. So untuk unit weight pada term number 3, you kena kira sebagai effective unit weight 17.8 tolak dengan 9.81 darab dengan 0.4 darab dengan B 1.5 darab dengan N gamma, you akan dapat 21.09. So you total up. So total up, you dapatlah 502.56. Okay, this question also asks you two things. For the first one, ultimate bearing capacity. Okay, ultimate bearing capacity considered done. Kita dah settle lah untuk 5 cases. So now, how to calculate the allowable load using factor of safety? Consider the groundwater table effect on all cases. Atau dalam case ni saya hanya select case je lah, saya tak tunjuk semualah. Okay, contohnya sebabkan kita nak dapatkan allowable load tu. So just now we have calculated the Q ultimate and then you need to calculate the net ultimate bearing capacity. So bila kata net tu is the ultimate tolak dengan overburden pressure. So overburden pressure kat sini bergantung kepada effect of water table. So don't simply calculate lah. You have to check carefully. Kalau you nak calculate case pertama, so overburden pressure ni mesti efektif. Kalau you calculate untuk case number 3, so overburden pressure you, okay, overburden pressure you kena ambil yang biasalah. So you tengok sini 17.8 darab dengan 1, dia tak tolak pun dengan 9.81. Okay, let's say you all done calculate the net ultimate bearing capacity, factor of safety dia dah bagi 4. Kemudian kita nak dapatkan net allowable bearing capacity. So apa yang kita perlu buat adalah net ultimate bearing capacity bahagi dengan FOS. So we got 105.5 for the case 1 for example. Kemudian area of footing kita dah tahu. So we have got 2.25 meter square. And then the net loading, macam mana nak dapat net loading? Assuming that the net allowable footing is also similar to the net loading Q. So remember just now I said the contact pressure is equal to the Q besar bahagi dengan area kan, area of the footing. So kita nak dapatkan Q besar. So Q net allowable which is similar to the contact pressure Q. So you darabkan dengan A, so you akan dapat the net loading. So you can see lah for all respective cases from case 1, case 2, case 3, case 4 and 5. So that's end for example 1. Okay, example 2, this is a different type of question whereby you are given informations on the particular footing such as circular, and you are required to determine the dimension of the circular footing which carry 1.4 meganewton of the column load at the depth of 1.2 meter in cohesive frictional soil, having this kind of properties. Okay, consider the water table is well below the footing and take the factor of safety against the shear failure as 2.5. And then these are the Terzaghi factors. So the second question, what would be the factor of safety if the area is flooded? So before you can answer question number 2, you need to find what is the dimensions of the footing, circular footing. So from the first one. So how to answer this question, solution 2 ataupun example 2. For the first one, because it is stated that the footing having the effect of water table at the well below. So at this particular one, you calculate the ultimate bearing capacity for the circular footing is 1.3 CNC plus overburden pressure and Q plus 0.3 B gamma N gamma. And since the water table is well below, so it means that all the conditions for the term 2 and term 3 will be in the total overburden pressure, for example, as well as total unit weight. So kat sini kalau you perasan, kalau ikutkan 17.8 is the unit weight of the soil. Disebabkan water table is well below, so the overburden pressure dia hanya calculate sebagai total sahaja. Dia tak tolak pun dengan 9.81. Same goes to the unit weight untuk term number 3. Sebabkan effect water table is quite far, kat sini pun unit weight dia hanyalah dia hanya ambil 17. Sekejap, unit weight of soil. Okay, 17. Okay, 17 kat sini dia hanya ambil 17 without minus dengan 9.81. So ini yang dia jatuh pada kategori case number 5, iaitu water table is well below. So there is no effect of water table in terms 2 and then juga in terms 3. Since we do not know the dimensions of the circular footing, so the remaining Q naught will be in the unknown B. So how do we get the B? Is by solving these sections ataupun this solution dengan cara Q net ataupun Q allowable is equal to the net ultimate bearing capacity over to the FOS. So just now kita dapat QU kan? Sebabkan dia nak net, so you kena minus dengan overburden pressure. This is the overburden pressure in the dry conditions. Nampak 17 kat sini dia tak tolak pun dengan 9.81. So we have second equation. This one equation number 1. This is equation number 2. So in this way, assuming that it's not assuming that from the equation 1, dia establish equation number 2. So the equation number 2 will be taking similarly as the contact pressure Q. So dalam this section, we say that the Q allowable footing sama dengan the Q contact pressure of the load. So in this one, kita akan dapat second equations lah. Equation yang kedua ni yang terhasil daripada FOS sama dengan equation yang seterusnya. So you samakan persamaan tersebut, you akan dapat B sama dengan 1.51. The dimensions ataupun the diameter of the circular footing is 1.51. So the next one is asking on the factor of safety. Okay, dalam factor of safety, it says that what would be the factor of safety if the area is flooded? So dalam kes ni, untuk you ambil kira ultimate bearing capacity, you need to consider the effective. All those term dalam term nombor 2, term nombor 3, dia mesti dalam keadaan efektif. Contoh yang ni, term nombor 2, effective overburden pressure. Term number 3 is a effective unit weight. So at this thing, you akan dapat the ultimate bearing capacity is a 1694.88 kilonewton per square meter. So what is the final answer FOS? So who can give me answer? Okay, take your time. Ambil calculator, ambil pensel, ambil kertas. Cuba kira berapa nilai FOS. Okay, later I need the answer from Okay, I nak jawapan daripada salah seorang anda. Seorang daripada jawapan dari lelaki, satu lagi jawapan dari perempuan. Okay, cuba kira berapa nilai FOS. Okay, cepat. Macam mana kita nak kira FOS? Okay, just now daripada questions. Okay, how to answer these questions? Okay, QU is equal to 1694.88 kilo Pascal. Okay, we want to have the FOS. Okay. Apa yang kita boleh kaitkan antara FOS? Okay, we also know that the net allowable ataupun gross safe bearing pressure is equal to the Q and net ultimate bearing capacity over factor of safety plus dengan overburden pressure. So, yang mana kita tak tahu? Yang kita tak tahu adalah FOS. Kita juga tak tahu Q net allowable. Okay, overburden pressure ni kita boleh calculate. Overburden pressure sama dengan effective unit weight darab dengan founding depth. Okay, the next one is a QNF. QNF pun kita boleh calculate, iaitu QNF sama dengan QF tolak dengan overburden pressure. Okay, what is the allowable net pressure? So this one, we may assume that the Q allowable net solve is similar dengan Q allowable daripada loading. Okay, cuba kira. Q allowable loading ni kita boleh dapat melalui contact pressure bahagi dengan area. So you akan dapatlah Q allowable solve. So you substitute kat sini, you rearrange balik equations, so you akan dapat nilai FOS. Okay, I give it you 5 minute times untuk you calculate what is the last answer for FOS. Okay, cuba kira. Okay, I nak answer daripada jawapan daripada lelaki Ashraf. While answer from girl from Azwa. Bagi saya nilai FOS. Okay, berapa nilai overburden pressure? Okay, overburden pressure sama dengan 9.19 darab dengan 1.2. Okay, berapa jawapan 9.19?
11.028.
11.028. Okay. And then the next one is a Q and F. Q and F sama dengan QF tolak dengan overburden pressure. So, kenapa saya letak efektif? Sebab dalam ni dia ada effect of water table. Okay, kita punya QF tadi 169.4.88 tolak dengan 11.028. So, apa jawapan?
1683.85.
1683.85 ya. Okey lah. Ini pandai faham ni. Okey, kita dah tahu overburden, kita dah tahu Q and F, kemudian kita nak tahu Q allowable. As I said just now, kita assume Q allowable solve sama dengan contact pressure coming from the load. Okey. It is equal to intensity load bahagi dengan area of footing. Intensity load is a 1.4 times dengan 10 power 3 kPa bahagi dengan pi diameter tadi berapa? 1.51 kuasa 2 bahagi dengan. So what is the Q allowable? Q net allowable. Okay, berapa jawapan? Yang lain tak ada kalkulator ke? You tak ada kalkulator? I ada.
1.78.
Berapa? 2?
792.
392 point? 392 point?
792.
7?
7.
7.
Okay, 392.7 lah.
792.24.
Okay. Okay, 792. Okay, ni jawapan awak lah. So, the next one. So, kalau perasan tadi kan, kita back to this top one. Just now, as I said, kita tak tahu. Yang merah-merah ni semua benda yang kita tak tahulah. Ini kita tak tahu. Ini pun kita tak tahu, ini kita tak tahu. Of course, yang ni lagilah kita tak tahu kan sebab kita nak cari dia. Tapi kan, kalau you tengok tadi, kita dah kira dah. Q&F dah kira, sigma efektif dah kira, Q net allowable pun dah kira. Kenapa dipanggil net Sebab kalau this case dia ada satu lagi tambahan kat sini. Tambahan satu value lah iaitu effective overburden pressure. Ada setengah buku dia tak ambil net tau, dia just ambil Q allowable. So you akan nampak at this hujung ni dia tak wujud. Sorry. Maksud saya kalau dia bukan net hujung ni dia tak consider pun dalam calculations untuk dapatkan the value Q net allowable. So please be careful lah bila you nak calculate that things. Okay, since kita dah tahu semua benda, Q net allowable dah tahu, Q and F dah tahu, effective overburden pressure pun dah tahu. Can you give me the last answer FOS? What is the value FOS? So
2.16.
Okay, that's correct. So same answer with me. 2.16. So kalau you tengok notes tadi kalau you tengok notes awal-awal tu saya ada bagi kan FOS, ada yang setengah calculation dia just take it directly as a QF bahagi dengan Q allowable. So this is also acceptable lah, tapi as I said in this class, since I taught you this way, so please follow as exactly what you have learned in the class. Similarly, when you have some appendix in your test ke apa benda dalam soalan kan, look at to the question carefully and all informations given to you supaya you tak salah guna info. Itu yang penting. Sebab bila you belajar kan, kita punya reference book is not only one textbook. Kita akan ada additional books untuk rujukan. So you akan nampak, okay, Braja M Das buat macam ni. Kemudian Whitlow buat macam ni. So all schools taught ada pelbagai cara untuk calculate the value of FOS. But I don't want you to get confused and saya pun tak nak ada the variety of answers. So I just say that this is how to calculate the allowable ke, nak calculate FOS ke. Ini cara dia. So kalau you nampak tadi, this question is not straightforward to have that FOS lah. So I show you how to get also from the Q allowable ke benda kan. So dia relate from the top on soalan kepada soalan akhir. Okay, so I think that that's end for this week punya topic 2. Do you have any questions before we end? Okay, the remaining topic on macam contohnya settlement ke, estimation settlement, etc. semua tu, just read on that examples, macam mana nak buat calculations dia. And then for other than that tu, kita carry forward after cuti lah. Contohnya deep foundations tu kita akan cover dalam minggu seterusnya. Okay, if you do not have any questions, so I end my lecture here. Okay, Assalamualaikum and have a good day.
Thank you.
Doctor.
Thank you.